Hey guys, here we are doing some simultaneous equations. Now this is called the substitution method because we're going to substitute one equation into the other. Okay, so normally when you solve an equation, it might look something like this. It might just be x plus 8 equals 21. Okay, and you would take 8 away from both sides to solve for the x, and you'd be left with x equals a number. In this case, x would equal 13. Okay, what we have today, we don't just have an x, we've got an x and a y. We've got an x is equal to 5, and we've got a y is equal, well, we've got x's and y's in this equation, okay? So in this case, we've got two equations. We've got two letters. If you want to be able to solve for both the letters, you actually need to have two equations. So you can put one equation into the other, all right? And I'll show you what I mean by that. So we are going to use one equation to help us solve the other equation. Because if you have a look at this one here, there's an x and a y in there. Now what's nice about this equation, however, is that we actually know we've been given this other equation where x is just equal to 5. So what we can do is we can take this 5 and we can put it in here in place of the x. Okay, so instead of the x, we know that x is equal to 5. So instead of the x, we can just write the number 5. So let's do that. Because we know that x is equal to 5, we're going to rewrite this equation, but we're going to put this value in there for the x. Okay, so y is equal to 3 times 5 take away 12. And now, because this equation only has one unknown, we can use our mathematical skills to work out what it is. So what's 3 times 5? Well, that's 15. We've got take away 12. So y is equal to 15 take away 12. Now 15 take away 12 is just 3. Okay, so we need to say what are both of our values? Well, we already knew that x was equal to 5. So we've got x equals 5 and we've got y equals 3. Now if I was to graph these, that would mean that the point where these two equations meet is at the point where x equals 5 and y equals 3. And we write coordinates just like this, okay, where x is 5 and y is 3. X is the first one, y is the second one. So here's our answer. X is 5, y is 3. I would like for you to write it like this, please. 5, 3. With a comma and brackets, of course. Okay, let's have a look at our next equations. We've got two equations here. Y is equal to 12. And y is equal to 2x plus 4. Okay, again, we've got two letters, but we've got two equations, so we can find out what both of our letters are. If we had a single equation that looked like this, y equals 2x plus 4, we wouldn't be able to solve for either the x or y because there's an unlimited amount of numbers that they could be, okay? Which is why it's great we've got this first equation where we know that y is equal to 12 because we can actually substitute the 12 in for the y. Okay, so instead of the y, let's substitute in this 12. And let's write 12 equals 2x plus 4. Okay, remember we're trying to solve for the x, so we want to get rid of everything on the side where the x is. So let's get rid of this plus 4 by subtracting it from both sides. Minus 4, minus 4. That leaves me with 8 on the left, and I've just got this 2x on the right. So 8 is equal to 2x. Okay, what is the opposite of timesing by 2? Well, it's dividing by 2. So let's divide by 2 and divide by 2. That leaves me just with x equals 8 divided by 2, which is 4. So x equals 4. All right, so do we have everything we need to know now? We know that x equals 4. We already knew that y is equal to 12. So the point at which these two lines would meet when x equals 4 and y equals 12 would be 4, 12. Okay. Last question. Now this one is a little bit more complicated, but same sort of thing. We are going to put one equation into the other. Okay, let's have a look at the equations. Now both equations here have x's and y's in them. So this one has an x and y, and this one has an x and y. All right, that's okay, but we can still put one into the other. I know that y is equal to 2x plus 3. So what I'm going to do is I'm actually going to replace this y here with the 2x plus 3. What I've got there highlighted are exactly the same because it tells me that y is equal to 2x plus 3. So instead of this y, let's replace it with 2x plus 3. So I'm going to write this equation out here again, but instead of this y here, I'm just going to write 2x plus 3. So that's the y, 2x plus 3. Then I've got plus 3 more x's, so plus 3x, and it's all equal to 23. Okay, now we have an equation that only has one letter in it. It's got x's and x's, but we can add those together and simplify. There's no y in there, okay? You can only solve an equation that has one unknown. All right, let's do some simplifying here. We've got 2x's plus 3 more x's. Now that gives me 5x's. So I've actually got 5x's plus the 3 is equal to 23. This is starting to look like a nice, easy equation to solve. All right, let's get rid of this positive 3, which means we have to subtract 3 from both sides. And that will leave me just with 5x on the left is equal to 23, take away 3 is 20. Okay, I've got times by 5, so I'm going to divide by 5 to get rid of that 5. If I divide one side by 5, I need to just divide the other side by 5, and that leaves me with x is equal to 4. Okay, so we know that x equals 4. Do we know what y equals? Well, we don't know what y equals just yet, but we do have this equation here that tells us that y is equal to 2x plus 3. So because I know that 4 is equal to x, I can simply replace my x here for a 4. So instead of 2 lots of x, I've got 2 lots of 4 plus 3. Now 2 lots of 4 is 8, plus 3 is 11. So I can figure out that y is equal to 11. Okay, there's my two coordinates. X is equal to 4, y is equal to 11. These two lines, if you were to graph them, would meet at the point 4, 11. And there's my answer.